Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 19, 2025, about 3 days ago. It shows that with a technique called Contrastive Activation Addition, theory of mind accuracy in a 4 billion parameter language model jumps from 32.5% to 46.7%, and that this boost comes from stronger emotional processing rather than from more analytical reasoning. The paper is titled Decomposing Theory of Mind, How Emotional Processing Mediates TOM Abilities in LLMs. And as we will see, this emotional shift inside the model has some surprisingly deep implications for how we train and interpret future systems. Alright, Figure 1 pulls this together by comparing baseline and steered activation patterns across broad cognitive categories. The left radar chart, labeled @question, shows that steering boosts emotional and creative activity while slightly damping analytical processes. The middle chart, @true, keeps emotional activation higher in the successful steered runs. The right chart, @wrong, shows that when the model fails, analytical activation dominates and emotional activation drops, which nicely matches the story that perspective taking leans on emotional processing. Well, Figure 3 zooms out to category-level patterns, which makes the emotional shift very concrete. The left bar chart shows that steering consistently boosts creative, emotional, and metacognitive activity at each time point, while analytical activation drops below baseline after the model gives an answer. The right violin plots summarize the spread of these effects at the answer token. Emotional and creative categories have strong, reliably positive shifts, while analytical processes show wide variability centered near 0 or negative. Alright, Figure 2 drills down from categories to specific cognitive actions, so the emotional tilt becomes very explicit. The left panel, @question, shows big positive shifts for emotion perception, emotion valuing, and noticing, while questioning and convergent thinking drop. The middle panel, after true answer, keeps emotional actions elevated and pushes questioning even more negative, which suggests that successful perspective taking relies on feeling into the situation. The right panel, after wrong answer, flips this balance, with analytical actions rebounding and emotional responses weakening. So while Figure 2 listed shifts across all layers, Figure 4 ranks the single biggest winners and losers among cognitive actions. The top row highlights increases. Emotion perception, emotion valuing, noticing, and hypothesis generation rise most at both question and answer tokens, which shows that steering pushes the model toward emotionally colored hypothesis forming. The bottom row highlights decreases, where questioning, convergent thinking, and understanding sharply drop, especially at the answer. That pattern reinforces the idea that successful theory of mind responses depend more on emotional resonance than on cold analytical checking. So while Figure 4 ranked the extremes, Figure 5 maps all cognitive actions as a heat map over time. The vertical axis lists individual actions grouped into analytical, creative, emotional, memory, and metacognitive bands. The horizontal axis shows the 3 time points, @question, after true answer, and after wrong answer. Green cells indicate stronger activation under steering, whereas red cells indicate suppression. The bright green blocks in emotional and creative rows contrast with the orange and red patches in analytical rows, which visually reinforces the emotional shift in theory of mind processing. Alright, while Figure 5 visualized which cognitive actions shift, Figure 6 evaluates how well the linear probes detect those actions across layers. The top left plot shows average AUC-ROC peaking around layer 9, then staying strong through the mid layers before dropping at the end. The top right plot shows the best F1 balance near layer 28, so late layers trade raw discrimination for precision recall balance. The bottom plots confirm that precision remains high once past the early layers, while accuracy barely changes, which suggests that the main story lies in where the signal is most separable, not in overall correctness. So while Figure 6 focused on average probe quality across layers, Figure 7 contrasts the best and worst individual cognitive actions. The full figure plots area under the curve for each action across layers, which shows how cleanly the probe separates presence from absence of that action. The left panel tracks the top 10 actions, where suspending judgment and counterfactual reasoning stay near perfect across most layers. The right panel tracks the 10 weakest actions, where emotion responding and understanding fluctuate more sharply and never reach those same discrimination levels. So the big message is that steering theory of mind in large language models works mainly by amplifying emotional and generative processing, while analytical reasoning actually dials down. That result, plus the linear probe framework, gives a concrete toolkit for dissecting future social reasoning systems. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.